Okay, so here is our initial scan, the vertical orientation, and a few things I want to bring to light here. Notice, obviously, there's no data on this information looking straight down on it and straight up on it. Obviously, that's because it was only capturing it like this. The other thing is, if you notice, there's a little bit of extraneous data in this. And so I'm going to use the trim tool. I'm going to do this really quickly because we have another entire scan that we're going to do it a little more extensively on. So using the trim tool, I'm going to use one of the simpler tools, the circle brush selector, and I'm just going to highlight that information and trim it out. So that's as easy as it is to remove extraneous data. So here is our vertical, and let's jump into our, this is our horizontal. So here he is sitting flat against the base. And so again, we need to remove all this information down here. Now we could do this with this circular brush. If you notice, I'm just left clicking, holding, and painting over it. And then we could hit trim, and it would remove it from all 7 of the scans. So there's 7 here, and there's 7 here. Okay, so we're gonna ultimately merge these two, but first we want to remove this data that we don't want. So another method to remove data is using a rectangular selector, something like this, and we could just very quickly remove it. I do like this circular one because it gives us so much kind of flexibility. And if I were to touch a little bit of the model itself, it shouldn't really matter because there is so much overlap for the most part. And I'll show you what I'm talking about in terms of the data and the scan. So if we went to, let's say, the triangulation, if you notice, there's multiple overlays of triangulation here. In some of these areas, like the neck, for example, there's only one scan that caught it. But if you notice things in like where it really steps out, the shoulder, the arm, there's just about at least 3, if not more, scans captured it. So a lot of data and plenty of information being contained in the various orientations. So let's go ahead and finish cleaning this up. That looks good. Let's take it back into this colorway. Okay, so now we want to combine these two, right? And make sure that the system has them aligned. So what we need to do is actually utilize the align command. Now what this does is it gives us the 2 entire scans side by side with 3 balls that we're going to place in simultaneous locations. And using those point triangulations, the system will be able to mesh the 2. Now the direction that is given by the manufacturer is don't place these balls perfectly vertical or perfectly horizontal, and don't place them on the same plane. So just kind of maybe around the entire model in a true 3-dimensional form. So let's put one right at the apex of his forehead. And if you notice, they don't have to be absolutely correct or absolutely identical, I should say. As long as they're close to proximity, the system will be able to essentially calculate the scan data. So we're going to put another one right there on his knee, and let's maybe put one up here on his shoulder. So again, if you notice, these aren't really in any obvious geometric alignment, so it should give the system plenty of ability to align these. Now, the system also provided us with 3 additional balls. We could put those, they're not required. In fact, the manufacturer says they're just a nice to have, and really there's no need to put them on. We can also specify how refined we want our point clouds to be as they merge. They are at the highest level of detail, so we should be fine there. So let's go ahead and run the alignment. And if you notice, it popped both of them into this green. So it's now taking and processing up here, the 2 together, and voila. So if you notice, we now have pretty much, there's a little bit of void here that we could do something like a single scan or a panel scan to capture. But if you notice, it's not really critical data, and it will be able to basically, I would say, speculate what that looks like, and we'll be able to seal that. There's a little bit of, this was a mold, so there's a little bit of a lip here. It didn't capture all of that, but that isn't critical either. And we could eventually, we could even smooth that using this software or Mesh Mixer. So far and away, there's a little bit of a hole right here too, but I think you'll be surprised, or pleasantly surprised, when you see how well this will be finally fused. So let's go ahead and go back. And once we've done the alignment and the trim, we are going to go ahead and we're going to fuse it together, okay? So basically what that is saying is, right now these are just a series of scans that are overlapped, but we actually want to go ahead and take and merge them and begin that whole watertight process that would get us to something like a final STL or an OBJ. So let's jump into the settings of the fuse. And we could change the mesh fitting resolution. The default is fine. The volume merge, again, the default is fine. One thing that we could consider in this model is there are no holes in this model. And so we could say, we want to create a watertight model, fill all the holes. So even these little voids that weren't scanned. So that'll do a helpful step in making sure that this cleans up entirely. We could do some textual blending. There's not a lot of texture here, so I'm going to stick with all the defaults. This is how many points this model currently has and how many triangles. So you see there's a lot of overlap and data. And let's go ahead and apply that and fuse it. So we are saving a backup model, and I want to show you how many files and information is being captured just as a result of this one scan, so that you do have a sense of appreciation for how much data is required in something as high-end as our NextEngine scanner. So it's creating the texture map, it's regenerating. You can kind of watch what it's doing up here as it fuses the scans. And again, keeping in mind, so this is essentially 14 two-dimensional panels that have all been fused together. 7 and 7 automated through the system, and then we took those 2 and merged them using the 3 balls to combined. And if you kind of look at the model right now, and then it gets rebuilt, voila. So it's been cleaned up. Now, if you notice also, it spit the first 2 360 panels out, and it provided us with this final fused model, panel C, or kind of model C. And much cleaner, if you notice, much smoother. There are no voids. It is watertight, so it cleaned that up in there. And it really did extrapolate that quite well, if you notice. So, you know, not bad. Here is our model. And there's our scan. So now all we need to do is export that. And there's a few other things we could do. We could polish it if we wanted to. If there were voids that we wanted to fill or cavities, we could buff things out. We could even simplify some data. For the sake of this video, and also, quite frankly, I think the model doesn't look bad. So we won't do any of this on this particular model. We could do some CAD related pieces to it. For example, we could designate an orientation, and there it is. If we wanted to flip it another way so that, let's say, this were actually oriented on its side, or we wanted to orient it on its side, we could do that. If we wanted to confirm its base, we basically could say the base is 1, 2, 3. There's the base. So that's been confirmed. And we could even place an origin if we wanted to, let's say, right at the center of it. And so those are some additional, we could even create some spline data and some surface data right here in this software, or we could do it in the RapidWorks software, which I'll show you very quickly after we have completed this model. So lastly, let's go ahead and send this to output. And if you notice, there's a couple different options here. OBJ, STL. We could even send it directly to a 3D printer if this computer were networked or set up to one. We could even take it right into SolidWorks if we had that, that add-in. We could take it right into that RapidWorks that we do have. But for this video, I'm going to just save it as an STL. And I did create this Monk folder. So let's go ahead and save it in there. And binary is the best option in that it carries the best bang for its buck, the least amount of data with the most amount of detail. And so we can now look in this Monk folder. So take a look at how much data is in here. Those are all, if you notice, each 2D view has been captured. There's also a ton of raw data that are the fragment files. It does do backup scans or backup saved files in case we lose our file. And then this is our STL. So if we look at that, this is what we would be essentially sending to our 3D printer. Having a little hard time. Here you go. So it's a little difficult to orient in here, but not a bad replication of that model that we had. Now, if we wanted to, we could bring it into RapidWorks and we could do some manipulation or even a certain degree of replication with something as organic and fluid as this. It's close to impossible to get something like a feature tree like you would see in SolidWorks. I mean, this is surfacing at its finest. You really don't have any true extrudes, for example, or sweeps in this. But there are, in here, if you notice, there is the ability to create sketches or turn items into solidify things of this nature. So let me see if I can open this really quickly. Desktop, Monk, let's see. So we could do the scan of the Monk. We could bring in an STL, but I just want you to get a quick visual of what you might be working with in RapidWorks. So if you notice, it's taking all that data, all that raw data, all that point cloud. So it's quite a large file, and there it is. And if you notice, here's the series of families. So these are each of the 2D scans. And then from here, we could really start manipulating this file to clean information, to start extracting information. So hopefully soon we will have an entire separate video tutorial on RapidWorks itself. But this just is a quick overview, because if you were to bring an STL or an OBJ or essentially anything of this file type into a CAD software, there's really nothing you can do with it. The CAD software does not see it as anything beyond just a file without any type of touchstone or point for it to hold on to. There's no grip for it. There's no planes, there's no surfaces. So this is the software that would provide us with that, that opportunity. Okay, so that in essence is our NextEngine Scan Studio. Now we could take this and we could turn around and 3D print it. We could put it in the Roland. We could take it as that STL file and we could send it elsewhere, and it could be printed and replicated around the world. So I hope that quick overview of the NextEngine helped.